So if I analyze this route by route, bulb A is bright because there's one bulb. Bulb B, there's a route where bulb B, where it's just bulb B. So that makes bulb B bright. What's tricky is I think, okay, maybe B and C are going to be dim, because I went through two. But there's a shortcut right here. If we imagine these are cars and they have to pay a toll here, nobody is going to go through C. Anyone that comes through here, they're trying to get back to the negative end of the battery. Why would you go this way? There's no reason to. So C will be off. That one will actually be, if you get that one right, that one will be extra credit on the quiz because it's not something we really talked about when we went over these. Alright, moving on to the next page. So steel B. And we're going to break these into two parts. First thing I want to check is, did I get my routes right? And my circuit type correct? And as Andrew said, we're now going to refer to these as resistors instead of referring to them as bulbs. So all I want to do is check, are there two routes and is the type a combo? Is that correct? All right, please show me your cards, group 1. I see 3 rights and a wrong. The correct answer is wrong. So a point for blue. Why is this one wrong? Charmaine. All right, what should it be? That is correct. It should be parallel. All right, did you get a point for Charmaine? All right, next thing I'm going to check. I said I have 9 volts to spend, or question? Yes. All right, great question. And can I get somebody to answer that for a point? Why is this one parallel? What is our definition of parallel? Go with Mr. King.
Parallel is when you have more than one route, but each route has only one.
That is exactly correct. That's kind of a long definition. Can I get somebody to repeat it? Put a point for the blue rules. Then after I call my next person, I'm going to pick on somebody, so I won't need hands after this one. All right, but repeat that definition of parallel for me, Charmaine. That is exactly correct. Repeat that definition for me, please. Yes, a point for Matt. Repeat that definition for me, please. Tony. Repeat that definition for me, please. Scott.
More than one route. With each resist on each route.
Say that again, please. Scott.
More than one route with one resist on each route.
All right, Tony.
So more than one route
With one resistor on each route is our definition of parallel. No points for that part. All right. So next thing I want to check: are my voltage drops correct? I said I have 9 volts to spend, so I'm going to spend 4.5 volts here and 4.5 volts here. Is that correct for my voltage drops? Please show me your answer. Group number 4. I see 4 wrongs. You guys are correct. These are wrong. What should it have been? Charlie.
It should not.
You got this.
When it goes through one. When it goes through just one.
What are these called, class?
Just resistance. When it goes through one resistance, and give it all of the.
And then when we go around this one, all your volts there. Very nicely done. So I could see inside Charlie's head. Charlie was thinking about walking around the classroom with 9 washers. So very nice. On this one, I said this is 2 routes. And this is a combo. So first I just want to check, is that part correct? That it's a 2-route combo. Please show me your answers. So hands on your card. Please show me your answers, group 3. Everyone says this is right. This is right. Very nicely done. Charmaine? I don't need you to. I think we got this one down. Thank you, though, for offering. Let's go to B3.
Did you want to do the voltage drops?
Oh, my bad. Yeah. All right. Next one is I want to know, are these right? Are my voltage drops right? My fault. Please show me your answers. So hands on your cards. I still miss a few hands on cards. And please show me your answer, group number 1. I see 4 rights. This is right. And now, so points for everybody. And now let's go to our next one. So for B3, please take a look at that one. All right. I said this one was a 2-route combo. Is that correct? Please show me your answer. Group 2. I see 4 rights. Everyone is correct. And Ms. Farmer, we go down a little bit so we can see the voltage drops. All right, now let's check our voltage drops. I said A and B each get 6 volts. C, D, and E each get 4 volts. Is that correct? Please show me your answer. Have your hands on your card, please. Please show me your answer, group number 2. I see the correct answer is right. Points are yellow, green, and blue. Ms. Brown said you can step outside. Alright, and actually, this one is correct, but I do want an explanation. How did I know that these were both 6 volts? How did I know that each of these were 4 volts? In general, what is my rule about spending voltage? What is my general rule about spending voltage? Renatus.
On your general rule about spending voltage, you will spend all of your energy for each volt at terminal.
Alright, I would change one word on that definition. That was great, but I want to change one word on it. After I get this perfect one, I'm definitely cold calling on somebody else to give me a perfect definition. That was pretty good, but we got to change one word right there. Please give me, no we don't. Please give me our general rule for voltage. Harlan.
General rule of voltage is that you want to spend all
Still a word we shouldn't be using was in there. And I also want to use the word routes. Please give me that. Please give me the correct general rule for voltage, Mr. King.
General rule both is you got to spend all your voltage on a route before you get back to the big end of the battery.
That was perfect. Please give a point to the Blue Wolves. And please repeat that general rule for voltage for me. Cedric. Alright, remember if we don't hear something, we gotta ask a question. It is so important. We got a quiz on it tomorrow. I'll take a volunteer this time. If you didn't hear, please ask to have that repeated. So actually, repeat it for us, Mr. King, and I'm going to call on someone random.
General rule for votes is you must spend all your votes before you must complete route to the end, to the negative end of the battery.
All right. And to simplify it, as we go around one route, I must spend all my voltage before I get back to the negative end of the battery. So it can be said either one of those ways. Please repeat that for me, Cedric.
Spend all your votes.
And that's on each route. So on each route, I must spend all my voltage before I get back to the negative end of the battery. One more time for me, Angelica. So no, I didn't catch the last part. Say it again, please.
Before you get on
Close. Let me get a volunteer to do it, and then I'll come back to you. Chris.
You must spend all your votes before you get to the negative end of that.
All right. Angelica.
You must spend all your votes before you get to the negative end of the battery.
Exactly. And we're looking at it one route at a time. All right. Let's go to the next one, Ms. Barner. Yes, Terrence, my bad.
I was gonna say, and they all supposed to be equal. They're supposed to all equal as the same one. Because you like, that's how don't, like if it's 12, don't put 4 on one end and put 6 on the other. I mean, 8.
Yes, that is true until you get to the honors problems. If you want to try the honors problems, then they're unequal. So great point though. All right, this next one. I said 6 volts, 3 volts, and 3 volts. I'm going to go ahead and tell you right now, these are wrong. Why? Why is this one wrong? Mr. Moore.
Because it's short circuit.
That is correct. And he said it right. This is a short circuit. Oh, that's true. How should he have said it, Ms. White? Alright. Please give a point to the Green Wolves as well. Alright. And more importantly, why do Alexia and Mr. Barnhart say it like that? I can't even do it justice. So why do they say it like that? Shaka. Yeah, we can start a fire. Short circuits are dangerous. Please give a point to the Blue Wolves. And lastly, what should I put for my voltage drop for A, B, and C? Renatus. 0. So this is the one exception to the rule. If we see a short circuit, we are done with the problem. We write short circuit. Everything is, if you're saying right dim or off, everything is off. If I ask you for the voltage drops, these would all be 0. All right. Let's move down to our last section. All right. And we are going to, this is one route. This is a series. What I want to check right now is my source current 6 amps. Is my source current 6 amps? Please show me your answer. Is my source current 6 amps? Have your hand on your card's ready. And show me your answer, group number 2. The correct answer is wrong. Points for red, blue, and green. Why is this wrong? Why is this wrong? Charmaine.
Because it's only one route, and it's the same car same car going around the whole route.
That is exactly correct. All right, what is so definitely point for Charmaine. Oh, so Charmaine, what should this be?
2 amps.
Just 2 amps. Good. What can I do on here besides labeling these? Labeling these is very important. What else can I do to make it really easy to help me remember which ones to count? Chris.
draw your arrows, circle the arrows, circle the first arrow.
Circle the first current on each track. Chris, you're counting as a yellow wolf. Please give a point to the yellow wolves. Chris was originally a yellow wolf. All right, and
That's
right now I just want to check this one. I said the source current was 0.45 amps. I got 0.45 by doing 0.15 plus 0.3. I didn't make a calculator mistake. I want to know, is that correct? I'll give you a little time for this one. I want to know, is that 0.45 correct? My hint to you would be to draw these on and make sure you do what Chris asked us to do. Probably the trickiest part of any complete problem is what we got right here. All right. Please show me your answers. Group number. It is a Wolfpack challenge, so everybody's cards up. Please leave your cards up. We have this is wrong. So the blue and yellow each get 2 points. There was a mix. Some people are right, some people are wrong. Remember, everyone in your wolf pack must get it to get the points. All right. What was the answer supposed to be, and why? What was the answer supposed to be, and why? Charlie.
I know what Rick does.
0.9 is not the correct answer. I'm trying to break the tie. Is there a... Oh, my bad. It's not a tie. But anyways, still for a couple points. What was the correct answer supposed to be, Angelica? 0.75 is correct. Please give a point to which the yellow wolves. All right. How did Angelica get 0.75? How did Angelica get that 0.75? Mr. Moore.
I add 0.15, then 0.3, and then up 1. You add up both 0.3s because they are separate lines.
Yes. So that's what's really tricky about this. If you circle the first current on, you guys are so good at the routes. So if you just circle the first current on each route, it makes these really easy. This one I intentionally made tricky. I made these the same number, but they are different currents or different cars that Charmaine was talking about. And that was, a 0.4 that team. One other thing is this was not parallel. It was a combo. But in the interest of time, we're going to do our mastery check right now.